Good afternoon, everyone. Hope you enjoyed the buffet. I'm Pierrick Poulenas. I'm the CEO and co-founder of Picterra. We're a Swiss-based company. We're the leading AI SaaS platform for Earth observation analytics, making geoinformation accessible to enterprises. Climate change has been a thing for the last 50 years, probably even more. And I think we all agree now that the reality of climate change cannot be challenged anymore. It's definitely detrimental to our planet, the biodiversity, humanity, but it's also putting a huge pressure on our economies. We estimated that approximately 970 billion worth of assets are at risk because of climate change. Earth observation is obviously a way to mitigate that, but I will even go further, saying that it's an essential resource to mitigate climate change, but also to improve the resiliency of our economies and societies as a whole. Just to give you an example, using Earth observation imagery for fighting deforestation in Central America, or you can use Earth observation imagery to monitor gas pipeline in Central Europe. The good news is there is more Earth observation imagery available than ever before. Between drone and satellite, we are collecting more than 400 terabytes of imagery on a daily basis. According to the Silicon Valley Bank, this might represent a business opportunity of around $1 trillion. But to analyze satellite imagery and Earth observation imagery, the only viable way is to use machine learning. And this is where the problem and the trouble starts. Just to give you an example, if you want to train an algorithm that will be able to identify an object within satellite imagery, you will need a lot of different resources. And this includes, of course, data science, machine learning, but also software engineering, DevOps, and so on. And this process will take between 3 and 5 months. So the whole process as a whole is pretty inefficient and expensive. On top of that, approximately 90% of data science project and machine learning project, they never make it to production because of the complexity. So what we did at Picterra, we abstracted the complexity of applying ML to EO imagery, and we packaged this into a single SaaS product, giving our customers some machine learning superpowers. So our customers, they are able to train, manage, and deploy a machine learning model that we call detectors without a single line of code and in a few minutes. These detectors, they are able eventually to identify, count, detect objects within satellite imagery, but also they're able to identify some trends or to detect changes over time. The platform that we build is 100 times faster, so instead of taking months to develop an algorithm, it will only take a few minutes. It's 90% less expensive than any other solution on the market, even less expensive than in-house capabilities. And most importantly, the platform does not require a huge set of training data. Maybe just to keep in mind that to train an algorithm, this algorithm, before being able to identify an object, it needs to see a lot of this example, between 15 and 20,000 examples. With Picterra, the platform needs only few examples, and when I say few, you can start with really 5 or 6, 7 examples of the object that you want to detect to reach and to build high-performance algorithm. Now looking at basically the growth trajectory of Picterra, we've reached 1.8 million in ARR. We have approximately 100 enterprises customer around the world, and we had this nice growth of 9x year over year. At Picterra, so we are not only building a SaaS software, but we like to say that we're building a platform that enable our customers to tap into the largest store of latent value in human history, which is geospatial intelligence. We are empowering every company with real-time geospatial information, and our ultimate goal and vision is to make it as easily accessible as an internet search. Maybe to conclude this presentation, I told you about the training data that is required to train an algorithm. It's not only about the volume of this training data set, it's also about the diversity of this training data set. The planet is diverse, so when you deal with geospatial information and geospatial imagery, you have to deal with diversity. This is absolutely key, more than traditional ML application. Okay. So just saying that we've collected so far more than 30 terabytes of training data for geospatial imagery, which we believe is the largest library of training data ever collected for geospatial imagery. Thank you very much.